Let's look at the permanent disability model. How does the changes or the rate of changes goes from one state to another state? In the permanent disability models, you can see that you have state 0, which is, for this one it is healthy, and then for state 1, which is disabled, here is disabled, and then state 2, which is that. Okay, and you can see that the arrows, there's no arrows from state 1 to state 0. So from here you can write the probability matrix here as TPX00, TPX01, TPX02, where it goes from here to here. 0 is maintaining in 0, 01 is from here to here, 02 is from here to here, and then there's no such thing as 10, so it will be 0 here, the value, and there's also no such thing as 20, so the value here is also will be 0. And then if the person is in state 1, it can still remain in state 1, it will be TPX11, and then there's no possibility from 2 to 1, so it will be 0 here, and then therefore this probability will be equals to 1, because the summations of all of this is equals to 1, and here would be TPX1, 2. So for the permanent disability models, we know that the TPX00 it shall be equals to TPX00 bar, because once the person leaves state 0 to any state, state 1 or state 2, it cannot come back to 0, because from state 0 to state 1 it can only remain in state 1, or from state 0 to state 2, then it's that, right? So you cannot coming back to state 0. So this value and this value will always be the same. So from here we can get the probability equals to exponentials of mu x plus s01 plus mu x plus s02. Okay, if you draw the Q transitions matrix here, you are going to get here, here is negative mu 01 plus mu 02, and then here mu 01, mu 02, and then and so on. Okay, and then TPX11 remaining in 1 means that you are going to be in 1, so that means it's not in 1, 2. So it is not going to be in 2, because from state 1 you can either remain here or going to state 2. So this is equals to negative mu x plus s12. So here would be mu 12, this is negative mu 12, here is 0, there's no rate of going here to here, here will remain 1. And there's no rates of going from anywhere. Okay, so here it will be remaining 0. It's not probability, sorry, so it will remain 0. So for this case, TPX01, so that means that from state here going to state 1, what would be the probability? So if you draw the timeline here, you can see that, let's split the timeline into 0 and then time s and time t. Here time s and here time t. So we didn't really know when it will change to state 1, but once it's changed to state 1, and then it will remain in state 1. So from time 0 to time t, there's a possibility somewhere in the middle it will change to state 1. So the probability of changing to state 1 is the probability of SPX00 mu x plus s 0, 1. This probability of healthy, and then this is the rate of changing to state 1. And then here you are going to keep on staying in state 1. Keep on staying in state 1 would be this part. So you are going to stay in state 1 from time t minus s, from time x plus s until times t minus s. This is the remaining times of t minus s. So this would be the probability of tpx 0, 1. Okay, that's it for the permanent disability model. Thank you.